All right, we're here doing the A2 notes on exponents and radicals. We're going to start off with exponents. What you should know about exponential form, it's just anytime you have a number raised to a power. I like to use b as my base. Right? So that's our base number. And it's going to be raised to an exponent. We can call that x. A little example, if we have x to the nth power, you're just taking x and you're multiplying it by itself a total of n times. So this could be going on a lot, and this will just be n x's. Okay. Some properties of exponents, since we did a lot of properties last section. Some good properties to know: anytime that you have the same base, so these two numbers are the same, with different exponents, this is an m, that's an n, what you can do is add them. So an example, 3 squared times 3 to the 6th is going to be the same thing as 3 to the 2 plus 6, so 3 to the 8th. If you divide two numbers that have the same base but different exponents, you can simplify that by subtracting the exponential values. For example, 3 to the 6th over 3 squared, oops, that's a 6, is going to be 3 to the 4th, because 6 minus 2 is 4. Let's see. Oh, this is a biggie. Anytime that you have a to the negative value, or just any number to a negative exponent, you can take it down to what I call the basement, or the bottom of a fraction. For example, x to the negative 5 is the same thing as 1 over x to the 5th in the denominator. I do like to, I don't know, I like to say that your exponents can be happy or sad. Positive exponents are happy, sad exponents are negative. Pretty much if a number has a negative exponent, so it's unhappy, you can move it to another place to make it happy. I call it the attic or the basement. So if an exponent is unhappy in the basement, you can move it up to the attic where it becomes happier, has an attitude adjustment, and works through its struggles. We'll definitely get some more experience with this, especially with this one right here. All right, anything to the 0 power is 1. So 4 to the 0 power is 1. Anytime you have an exponent outside of a quantity, that's when you multiply. So it's kind of like the distributive property. You can maybe probe that into your brain. So for example, anytime you have like 2x to the 3rd, you got to make sure that you raise both x to the 3rd and also 2 to the 3rd, making that 8x to the 3rd. So just distributing that in. Here, if you already have an exponent inside of your parentheses, just multiply the exponents together. For example, if you had 3 squared inside of your parentheses, then you raise it to the 6th power. It would just be 3 to the 2 times 6, which is 3 to the 12th. This is really the same thing as number 5. If you have an exponent on the outside of the parentheses, just make sure that everything gets distributed on the inside. So say we have 2 over x to the 3rd. Just make sure that, again, the 2 gets the 3, and so does the x. Pretty much with this last one, know that if you have an even exponent, it will just have a positive answer. It's kind of like taking the absolute value. So if your exponent is even, it's going to make your base number, your answer, positive, no matter if the base is positive or negative. This is kind of difficult in your calculator. So even exponents have positive answers. For example, if you put -2 without parentheses to the 4th power in your calculator, it's actually going to give you a negative answer. That's why you need to make sure that you put it in parentheses. Maybe try those two. You'll notice that this one has a positive answer, and this is the right one. Okay. So just make sure that you know that if it has an even exponent, it's going to turn positive. All right. So practicing with these exponents, here, what I would say is combine like terms. For example, you could take the 4 times the 8 to get 32. And you have y squared and y to the 4th. 8 and 4 make 32. Here you have the same base and different exponents. If you refer back up to this property right here, that means that you can add them. And 4 plus 2 is 6. Excellent. See if I can zoom in a little bit. This next part, here we're going to really use that distributed property. Just make sure that everything inside the parentheses is given your exponent. So you're going to have 5 to the -4, x to the 2nd, and then take the 2, multiply it by the -4, you're going to get x to the -8. And here, -2 times -4 is going to be a positive 8. This is where the attic basement comes in. If you have an exponent that's unhappy where it is, you can move it so that it becomes happy. For example, 5 to the -4, unhappy exponent. Let's move it down to the basement where it becomes happy. 5 to the +4. Here, x to the -8, we got to make that a happy exponent. Move it down to the basement. Y to the 8, that's already positive. It's happy where it is. You can keep it in the basement. Last step, just take any number and raise it to the value that it's given. For example, 5 to the 4th is 625, so this is going to be 1 over 625. X to the 8th, y to the 8th. Awesome. Go ahead and try C on your own. It has some negative exponents, it has some distribution, and we'll come back to it tomorrow. Okay, scientific notation you definitely have done in science before, but just a little bit of a refresher on this. What you need to know, this value of C is going to be between 0 and 10. I would even say 0 and 9, so they actually go for decimals. So it's not going to be 10, but just less than. So it could be like 9.99999. This value for n right here, that's going to be either positive or negative. What you need to know is if you have a positive n value, then it's going to be a really large number. And in general, once we're working with these, you're actually going to move the decimal place to the right for this one. If your n value is negative, then it's going to be a small decimal. And that means that you're going to move your decimal place to the left. I like to show the movement of the decimal. For example, here this is in scientific notation. 3, 4, 5, those are the numbers behind the decimal point. Here we have 1.345 times 10 to the 2nd power. All you need to do is multiply, or not multiply, move the decimal over the same amount of times as the exponent. Again, this is a positive 2, so that's why I moved it to the right, 2, leaving you with 134.5. Here, going backwards, and here's really a big case as to why scientific notation is better to look at than this big old decimal with all these zeros. If you kind of count in here, I think, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8 place movements until it gets behind that 1. So to write this in scientific notation, you can have it as 1.283. And since you moved it 8 different places and you moved it, I guess, to the right, even though it doesn't quite go with that, since this is a really small number, it's going to be a negative value. Go ahead and try C on your own. Again, we'll come back to it. In your calculator, and I'm sure that you've run into this before, it's going to look like this. You're going to have a number and then the letter E and then another number. An example of this would be like if you had 6.5E3. This just translates to 6.5 times 10 to the third, which you can just get by moving the decimal place 3 times, so 6,500. Square roots, cube roots, you're probably pretty familiar with. Square root is just going to be the regular square root. So like the square root of 25 is 5. Any time that you have a number times itself, it's a perfect square number. Here you're finding that number. That's the root of it. Cube root, same thing. You're going to take, it's going to be this symbol right here with a 3 out front. Okay. We're going to do a lot more with roots. Let's see. And properties of those on the next page. They are directly related to exponents. They're like the opposite of exponents. So the definition of the nth root. So if a is equal to b to the n, b is going to be the nth root of a. For example, I know that 2 to the third is 8. So that means that the cube root of 8 is 2. In general, the properties of your root, this is going to be your radical. This is your index number, and that's really important to note so that you know what root you're taking. This is the radicand. And that's what you're going to be rooting. If you don't have an index, then you can assume that you're taking the square root. So no index means square root. Cool? All right. So let's see. A couple examples. If you're taking the 6th root of 0, anytime you have 0 underneath your root, it's just going to be 0. If you wanted to do this in your calculator, you could. The 4th root of 81 is 3, but if you didn't have that memorized or were unaware, you could always take 81 in your calculator and raise it to the 1/4 power. We're going to go over why that is in, I think, the next page. And it should spit out 3 for you. So then carry over the denominator, 3 over 3 is 1. The next video we're going to talk about some more properties of radicals. We're actually going to skip this right here. And then do a couple examples together. And talk about rationalizing your denominator. We should be good on A2. Okay. Awesome.